Today we're talking about telescopic sums. Now we discussed the idea of telescoping in our last video for our last problem, but we didn't really go much into detail with it. So that's what we're going to do in this video. In telescopic sums, AN is equal to Fn plus 1 minus Fn. That's something that's really important and that you do in all telescoping problems. So let's just start up with the most basic example that there is. 1 divided by 1 minus 1, 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 all the way to 1 divided by 99 times 100. So obviously this is an arithmetic or geometric sequence, but we can break it up to, we can notice that 1 divided by n k times k plus 1 is equal to this over here, 1 divided by k minus 1 divided by k plus 1. So let's just, since this has the same formula as this over here, that we can just put the value of this into here. So we're going to get that it's equal to 1 divided by 1 minus 1 half plus 1 half minus 1/3 all the way to 1 divided by 99 minus 1 divided by 100. So you'll realize that we can cancel a lot of this actually. So let's do that. So minus 1 half cancels with 1 half. 1/3 minus 1/3 cancels with the next one after. 1 divided by 99 cancels with 1 before it. And we're left with 1 minus 1 divided by 100, which also is known as 99 divided by 100. And there you go, that's our answer to our first example. Our next example is this over here, where we have an infinite sequence being 1 divided by k times k plus 2, where k is equal to 1 all the way to infinity. So first of all, you can notice that these two over here are very similar. So that's how we're going to solve the problem. The difference is that here in our first example it's 1 and here it's 2. So what do we do now? Well, if we make it so that 1 divided by k times k plus 2 is equal to 1k minus 1 divided by k plus 2, that would be wrong because this over here, oops, is actually equal to 2 divided by k times k plus 1. So we can just multiply by 1 half. If we put this into this over here, then we're going to get that it's 1 half times 1 minus 1/3 plus 1 half minus 1/4 all the way to infinity. So now what we have to do is make it so that many of this cancels as well. So 1/3 cancels with the upcoming ones, and these all cancel except for 1 in the last number. Well, this time our last number is 1 divided by infinity, which, as you probably should know, when in fractions, when the bottom number is bigger, then the smaller it gets. So 1 divided by infinity is so small, in fact, it's pretty much just 0. So we're just not going to count it. So now we're left with 1 half times 1, which is also known as 1 half. And there we go. That's our answer to our second example. In our third example, we have it so that we had to find the sum of 1 divided by 1 times 2 times 3 plus 1 divided by 2 times 3 times 4 all the way to 1 divided by n times n plus 1 times n plus 2. So the difference between this example and the other two examples we just discussed right before is that there's 3 numbers instead of 2. So can we still use the same formula? Well, yes and no. We technically can use the same formula, but we're going to have to use it twice. So we have that 1 divided by n times n plus 1 times n plus 2 is equal to 1 half times 1 divided by n times n plus 1 minus 1 divided by n plus 1 divided by times n plus 2. Sorry. So you'll notice that this is the same formula as this over here. And you'll be right, because here n plus 1 and n plus 1 are pretty much the same value, and the difference between n and n plus 2 is obviously, well, 2, leaving it so that we have to multiply by 1/2. So now you'll notice that this is very similar to this over here. So let's just put the formula in that in. We have that 1/2 times 1n minus 1n plus 1 minus 1n plus 1 minus 1 divided by n plus 2. So let's just put it into this over here in the entire sequence. So we have it so that it's 1/2 times 1 minus 1/2 minus 1/2 minus 1/3 all the way to 1 divided by n minus 1 plus 1 minus 1 divided by n plus 1 minus 1 divided by n plus 2. So now let's just cancel a bunch of stuff, right? So you'll notice that we can cancel. Here was the one ahead of it, here was the one ahead of it, 1/3 was the one in front of it, and 1/2 was the one in front of it as well. So we're going to be left with this and this. So let's just solve that now. So we're going to get 1/2 times 1 divided by, actually, well, that's actually just 1, so let me just write, this is actually just 1/2, so I'm just going to write that 1/2 minus 1 divided by n plus 1 minus, actually plus, sorry, n plus 2, 1 divided by n plus 2. This is pretty much our answer, so I'm just going to leave it at that. There we go.